right, guys, I don't love the order that your notes are in. So yesterday we did the first page front and back, which is fine. Skip the second page and go to the third page for me. Yes, ma'am. I'm sorry, look in the folder. All right, we're talking about exponential functions. So this is like growth and decay, which you guys have probably seen before. You've just forgotten. In its like most basic form, it's y equals a times b to the x, where a and b are constants. Now notice, based on your rules from yesterday, that little x does not affect the a. Those are separate. Only the b is attached to that exponent, so be really careful about that. When a is greater than 0, and in real life situations it will be, you are able to graph it if a is less than 0, but like for real life application it's always going to be positive. If b is greater than 0, it's growth. If b is between 0 and 1, like a fraction of some sort, it's decay. Growth, we're thinking about things like population, steady increases of population, or I don't know, money. Decay is like, I don't know, radioactive material that's breaking down over time or something like that. The parent function looks like this. The graphs, in their parent form, before you've done anything to them, they cross at 0, 1. Both of them. Growth skates along an asymptote that's on the x-axis. Whoops, come on, get my pen to work here. So it gets closer and closer and closer to 0 without ever actually touching it. And that's growth. Decay goes the other way. And it also crosses at 0, 1 with its asymptote that skates along just above the x-axis. Sorry, don't mind my Jake and the Neverland Pirates band-aid here. It's what we had. And he's cute. I like him. All right. Questions on parent functions and kind of what that's going to look like. Okay, I realize you have a calculator, but just in case you're not allowed to use one, let's figure out how to do this in a t-chart. We have our x's, we have our y's. You plug it in, you get your answer. So if x is -2, what's 2 to the -2? 1/4. 2 to the -1. A half. What's anything to the 0? 1. 2 to the first. 2 squared. 2 cubed. 2 to the 4th. So if we were going to graph that thing out, you can tell it's 0, 1 is one of our little places. And I realize you guys can barely see those little lines. Just kind of do your best. 1, 2, 2, 4. And it skates along that right there.
So we don't have to plot the other points exactly.
Not exactly, but it needs to be, I mean, I need to be able to tell that it's getting infinitely closer to the x-axis. And whenever you graph on today's worksheet, I just need like 5 solid points. Not bad. Now the next little section wants us to graph 4 different things. I'm going to save us some time. You've got a calculator, and I know you can graph by hand. So grab your calculator, type all those in, and let's look at them. Make sure that you put your calculators back into the function format instead of the polar coordinates. So go to mode and make sure that you're not in polar, which this one's not. So we have 3 times 2 to the x, -2 to the x, 2 to the negative x, and 2 to the x plus 2 minus 3. Zoom 6 will put it in your standard viewing window. Just kind of like a 10 by 10 kind of deal. And as they come in, you can kind of see the differences in the graphs. Yeah, it does take some time. Yeah, the colors help, don't they? So if you look at the difference between the blue graph, the first one that came in, and the second one, the red graph, what's the biggest difference you notice right off the bat? They're flipped over the x-axis. So this negative, much like if this was a quadratic equation or something, that negative is going to reflect it over the x-axis. How about the third one that came in? The black one. Came in the other way. It kind of looked like a decay, right? It's kind of what it looked like. So I think on that one we could say it got reflected over the y-axis. That's what happens when the x part is negative. Which makes sense. If the x coordinate is now negative, that's on the other side of the y-axis. So it makes sense that the whole thing reflects over the y-axis. How about the last one? It went down. It went down how far? So that right there went down 3. And it also, I don't know if you caught it, but it went left 2. So the right and left stuff is the opposite of what you think it's going to be. And then it also went down 3. Left 2 and down 3. Questions on what those little guys do? So that'll help you. You can always kind of go for the parent graph and then just make the adjustments. That's one thing you can do if you don't want to do the actual t-chart. All right, flip the page over. Same kind of deal, but we've got a little less than sign here. We can type this one in if we want to, or we can do the t-chart. Actually, let's do the t-chart because that's what you have to do on your assignment anyway. We just need like 5 points, so I'm going to do like -3, -1, 0, 1, and 3, and let's see what happens. 3 to the -3 minus 2. -3 minus 2 is -5. Whoa, 3 to the -5th. Whatever 81 times 3 is, what's that? So -243, is that what it is? So 1 over 243. Duh, that's what it would be. It is tiny. -1. -1 minus 2 is -3. 3 to the -3 would be 1 over 81. Nope. How about 1 over 27?
No.
81? I think I did 243 wrong. What am I doing? Thank you. 0. 0 minus 2 is -2. 3 to the -2 is? 1/9. 1 minus 2 is -1. 3 to the -1, or, yeah, 1 over 3. And then 3. 3 minus 2 is? 1, and 3 to the 1st is 3. So you might need to do, like, another one to get to there, but maybe not. Let's just see. So we have all of these tiny, tiny, tiny ones. And then we go 0 is a 9th, that's like tiny, tiny. And then 1 and 1/3, which still looks tiny, tiny. And 3, 3. 1, 2, 3. 1, 2. So you can kind of see it's going to have a pretty sharp upturn. Now, I've already done something wrong on this. What did I do wrong?
Let me see.
Dash the line. Thank you. So that should be dashed. How do you know which side to shade without checking it in your calculator?
Isn't it like if it's greater than 0 side?
Let's test a point and make sure. Let's put in like, I don't know, 0, 3. If I make x 0 and y 3, let's see what happens. Well, we know from below that on the right-hand side we're going to have a ninth. Is 3 less than 1/9? No, it's not. So if this point right here doesn't work, then none of these up here are going to work, which means all of these do. And do you know why we shade it? You know what the purpose of that is? Oh, one of my favorite pens just went. It's because, do you guys know people who have so many freckles it looks like they're tans? You know what I'm talking about? So if this works, and this works, and this works, and this works, and all of these points work, if I keep putting dots, if I put enough of them, it's going to look like it's shaded. That's why it's shaded. It's because all of those dots also work. Okie dokie? Go back to your second page. If you do not remember this formula from last year, you need to memorize it again. Where n is the final amount, n sub 0 is the initial amount, so that's how much you start with. R is your rate, and they're probably going to give that to you in a percent. You're not going to put a percent in there. You're going to make that a decimal, so make yourself a note. That should be a decimal. And T is the number of time periods. Sometimes it's not time, usually it is. So let's scooch down and check out our example. When kerosene is purified to make jet fuel, pollutants are removed by passing the kerosene through a special clay filter. Suppose a filter is fitted in a pipe so that 15% of the impurities are removed for every foot that the kerosene travels. Write an exponential function to model the percent of the impurity that's left over after the kerosene travels X number of feet. We're just going to write the equation.
Okay.
So you wind up with a certain amount. You start with a certain amount. And it's 1. And notice in the formula it says plus. Why am I going to put a minus? You are removing impurities. That's right. It's decreasing. So up at the top, put yourself a minus. It might be plus, it might be minus. You have to choose. Might be plus, might be minus. You have to choose. So we're subtracting 15%. So what do I write with my pen? 0.15, thank you. To the, and usually it's T and usually it's time. In this case, it's feet, and they want us to call it X. So for every foot that it travels, 15% of those impurities get removed. It says to graph the function. The problem is that I've got 3 unknowns. Now let's think of it like this. Let's say that n sub 0 is one just generic unit. 1. Pretend that that's the number 1. If that's the number 1 right there, do I actually have to write it? No, because if I divide both sides by 1, n divided by 1 is n. So your actual equation is going to be n equals, whoops, crap, sorry, 1 minus 0.15 to the x, or you could actually go ahead and simplify that and say n equals 0.85 to the x. Because 1 minus 0.15 is 0.85. And that's a function that you could graph, and you could do a t-chart, you could figure it all out.
But if it says to write, just write the function.
Mm-hmm.
You write the first one, the first version.
I take a different one.
So wait, how do we do that again? How do you run it?
Yeah, so
Okay, so let me say it again. We don't know what the initial amount is because they didn't tell us. Let's just pretend that it's 1 unit, whatever that means. So it looks like that, Carson. So to get rid of this 1, I'd have to divide both sides by 1. Carson, why can't I say 1 times this guy right here? Why is that not okay mathematically? Because these two guys are attached. So I hope everybody caught that. If this said 2 times 3 squared, can you call that 6 squared, 36? No! You deal with the 3 squared first, right? And then you multiply it by 2, so it's really going to be 18. Does everybody see the difference? Because of that, this does not mean 1 times the parentheses there. Divide both sides by 1. N divided by 1 is n. Carson, does that make sense?
Yes.
Okay. Everybody else got it? Okay, that's where that came from. Letter C. What percent of the impurity remains after the kerosene travels 12 feet? Well, where did I put the 12? X. So N equals 0.85 to the 12th. We type it in. What'd you get? What? Yep, it smells. You get 0.14. All right, so what is that in percent? About 14.2%. That's about how much of the impurities are left. So we've gotten rid of a lot after 12 feet. Question D. Will the impurities ever be completely removed so we can get to 0%?
No.
No, it's like halving something. If you half it for an infinite number of times, it just continues to get tiny, 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 and it never really goes away. There's always a little bitty, tiny, minuscule piece there. So the answer is no. Which is why there's an asymptote. It doesn't ever touch 0. It gets super close, doesn't touch it.
So you're just inferring that it equals 1, or do we find out?
We're just calling it like one sort of generic unit, and that's fine. You can do that. Alrighty, compound interest on the back. This is another equation. If you don't remember it, you need to know it now. Question, you okay? Don't be afraid. I don't want to know. Okay. A is our final amount of, typically we're talking about money here, equals, P stands for principal, that's how much you put in the account, times 1 plus, and we're going to be accruing interest, that's gaining interest, so these aren't typically subtraction problems. R is rate, which again should be a decimal. N is the number of times that it's compounded in a year. Sometimes they do that once a year, sometimes it's 4 times a year, sometimes it's every month, so it'd be 12 times a year. That same number gets used on the outside, and T is always time in years. Let's look at the problem down here. If you invest $5,000 at 2% interest compounded quarterly, then how much do you have after 3 years? I realize your calculator does all the heavy lifting. I need to know what you typed in. So we say A equals, what's our principal amount? $5,000 times 1 plus, what do I put for R? 0.02 divided by, what's N? How many times is it compounded in a year? 4 times, quarterly. That's 4 times a year. To the NT, so 4 was N. What's T? 3, because we're going to leave it in there for 3 years. Type all that in your calculator, find out what you get. Be careful about your parentheses, especially if you're on a TI-83. I heard it, $5,308 and 38 cents. Does that sound reasonable? Oh, so it's 39.
Why are you? Well, it's at 2%, so is that why it's
For 3 years, and they compound that interest 4 times a year.
So that's why.
So if you had gotten the answer 4,800, would you know something's up? Because you should be gaining money. If you've gotten like $10,000, you should know something's up and you type something in wrong. Or we need to go find out where that bank is, because that's pretty awesome.
Yeah.
Right? David, you good?
Yep.
Keaton, you good?
Yeah.
Questions from anybody?
Yeah.
All right. Let me get your assignment.
Oh, wait,
Yes, you do have it.